Hi, everybody. As Julian said, we are going to talk about self-selection. We're actually going to talk about a whole lot more, though. So I wanted to just let you know a little bit about why we're the ones talking about it. So this is Cory.
Hi, I'm Cory. I love my job.
Cory loves his job. As chief architect, it's my job to make sure that Cory loves his job and that all of the engineers love their jobs. And this is not just because I'm benevolent. As Julian pointed out, I'm actually kind of more chaotic neutral. It's that we get the best product out of people when they really love what they're doing. And so this is a talk about making our engineers and our individual contributors happy, but also making the organization happy. And when we talk about this, when we talk about this, it helps to really kind of like think about what it means to have that happy organization.
As Lou likes to say, I love my Mondays. And the thing is, I love my Mondays because it means I get to come to work at this place with this amazing culture of innovation. But about a year and a half ago, something had kind of changed, and I really couldn't put my finger on what it was. Till one day I was out at lunch with the team, and something crystallized for me. The topic of conversation was revolving around a feature we were trying to release, and I kept hearing people say things like, they won't let us get this piece of functionality out into the system. We can't do our jobs because of them. And the thing is, I've worked at other companies where I've heard this type of thing before, and it's never good. Partially because it means we have lost trust somewhere along the way. And the people we're talking about aren't our enemies. They're our friends. They're our coworkers. We respect them. We really genuinely enjoy working with them. But some point along the way, we started to look at them as if they were our opponents and as if they were standing in front of us trying to get our jobs done. And that really wasn't the case. And that stood out to me as a big problem, because in the places I've worked before where this has happened, it's always been a symptom of a deeper issue.
So, a lot of stuff happens in New Relic. We say, well, is this is just kind of part of doing business? Is this what we want? We look at this. This is like what we want out of New Relic. Lou talks about he loves his Mondays, but when we get more formal about it, we say we want New Relic to be the place to do your best work. This is subtly different than something you'll often hear when people say a best place to work. A best place to work might be really rad foosball tables, or kombucha on tap, which actually is pretty rad. But a place to do your best work is about where you can go to do things that you couldn't accomplish other places. And if other teams are like preventing you from doing your job, you're feeling that tension there, that's the opposite of a place to do your best work. So we had to jump on this. It wasn't just Cory and his conversation, but it was this kind of insidious feeling that maybe things were starting to be more like other places we'd worked in the past and less of this special place. So when we dig into it, what is Cory's conversation about? It's about distrust. The team that he is on doesn't trust that the other team has their best interests in mind. They're saying, they aren't letting us do the things we want to do. They don't want us to ship our software. Obviously, this is false. We're all in it together, but we've lost that trust. The way that we lost that trust is simple, is that I say, hey, can you go and do this thing for me? In order to ship my feature, I need you to provision 100,000 database instances, or I need you to reverse the entirety of human knowledge. And the other team says, sure, we'll do that, and then they don't. All right? I've lost trust. Why didn't they do it? Are people just too eager to say yes? At first, it seemed like that. We dig into it, and what we see is that it's the way that the teams are working that's causing the problem.
And one of the side effects that we see from this is that we're doing lots and lots of work to the point that we actually have multiple projects going on simultaneously, because we're trying to compensate for the fact that something else didn't get done, so we need something to do now. And unfortunately, that means we're getting later and later and later delivering the things that we are delivering. And by the time they actually get delivered, it's really expensive to go back and rework them when we get feedback that says that we need to make a change. The task switching alone, the costs there are so high that it becomes prohibitive to go back and make these changes. And that leads to us doing wasted effort. And engineers hate wasting effort.
So you key into a couple of themes here already. You know, it seemed like a distrust problem, but then when we dig in, we say, well, what are we really underpinning that? It's underpinning it is cost switching, like rework. These are pretty fundamental queuing theory issues, and we're often attributed to long lead times. Lead times is something that, you know, is from the manufacturing world. You'll also hear us talk about it a lot in management circles. This is the time when we describe lead time, we mean between when we decide to do something and when it's in a customer's hand or it's generating value for the business. The longer these lead times get, the more opportunity there is to do something wrong and kind of make a choice along the way that has to be fixed later. Then that leads to the teams being oversubscribed in multiple tasks. That leads to dropping of commitments and distrust. And then we're not the best place to work or place to do the best work anymore. So we have to address the lead times. On the other hand, is this maybe just what happens when you get big? When I joined New Relic, there were 12 engineers, and we pretty much all just worked together on a project. We would sit down, and everybody would say, oh, well, what's the thing that's going on? Oh, you know, well, this product is slow, or we need to build this feature. Everyone would come together. We would all work together and solve it. But the things we could do were pretty small. We saw a market with lots of opportunities, and we could only pursue a few of them at a time. Said, well, you know what? If I had a few more engineers, we could really solve this. We could take care of this stuff and do more. And before you know it, we are a 1,000-person company, and we have 250 engineers. And we still feel like, you know, if you had a few more, you could do, you know, get a few more things done. But maybe it just isn't going to feel the same to have a 1,000-person company as it does to have a 30-person company.
I used to work in the hardware industry, and when we started experiencing these problems, it reminded me of a very similar problem that microprocessors went through about a decade ago. If you think back and you remember, it was all about clock rates and longer pipelines. They kept increasing the length of the number of stages in a pipeline to more and more length so they could get more and more instructions in flight at once. And the idea was they're trying to utilize that hardware, get as close to 100% utilization as you can.
Sound familiar?
Here's the problem. To do that, you also have to embed tons of custom hardware to predict branches, so you can keep that pipeline full by predicting what's going to happen next. And that all works out great until you're wrong, and you have to dump that whole pipeline and start over from scratch. There was a tipping point where it cost more to dump the pipeline than you got in terms of performance benefit for making that pipeline so long. The hardware industry stopped and said, well, we're going to change how we do this. We know shorter pipelines are more efficient. We're going to put more of them in parallel. We're going to work on multi-core processors. And we're going to shrink the pipeline so that the cost of making a bad decision is much lower by knowing about it sooner.
Everybody here is familiar with the effect of this. We went from having these giant single core work units in the processors, moving the long pipelines through, to now everything is like, you know, 40 cores. We had to change the way we wrote software, the whole way we thought about CPUs. But it solved the problem. We got a lot more out of our CPUs today than we did 10 years ago. We were able to continue to cheat the limits on that system. Is our organization the same thing? You know, we were looking at putting more and more effort into choosing the right work and sequencing our work as we're going through. We've got, you know, fancy charts, we have program management, we have all these things to ensure that the work units arrive at the teams who can handle them and that the load is steady. We can change this. We just have to change the way we think about our entire organization. No problem, right? To realize that when we saw distrust between teams, it wasn't an individual problem. It's not because there was some bad apple on a particular team who just isn't doing their job. It's not because that team is a low-performing team. Oh, well, the provisioning team isn't keeping up with the demands of every product team ever. So, like, you know, it must be an issue with the performance of that team. No, this is an organizational problem. This is like the architectural shift in the CPU. We need a big fix to address this.
Sweet. Let's have ourselves a reorg. That always fixes everything.
Right? Org problem, reorg. Everyone's favorite. Always worked before, right? So, okay, we've been there. We know the reorgs suck. We've tried it before. We did reorgs before at New Relic. You say, hey, guess what, Cory? You know what? Your boss's boss is going to be somebody else now. And I think that renaming of your department and changing VPs, that's going to just energize the heck out of you.
That's all I need to get my job done.
So we make fun, but ultimately, I'm going to be honest, we did a reorg. That is what it means to change an architectural problem in your organization. We just wanted to do a reorg differently than the way we have done them before. We wanted to do a reorg that's more kind of the way we build software. We don't build software by taking, our executive management like off-site for like 30 minutes, like to go somewhere nice, maybe for like a day of like eating in a nice restaurant, watch the golf course, then we're going to hit the flip charts and really break some wrists. No, that's not how we make products. We make products by digging in.
Look, we're engineers. At New Relic, we've got a bunch of really, really smart engineers. They're really good at solving very complex problems. Why don't we take all this brain power and see if we can solve this problem?
So, right, we hire those smart people, let them be smart. This is our philosophy for how we've been building software. This is also the philosophy for how we ran this organizational change. This change was not orchestrated by me and my VP buddies, at some beautiful location. This change was done by individual contributors, by engineers on teams, by product designers, by product managers, getting together and working on this as if it's a real project. We worked on this from January through to April, pretty much full time for a team of 10. That ended up being maybe a little too much effort, but it's hard to see in retrospect how some of these changes would have come out for less investment. And I'm very happy with the decision in retrospect. It did give me some pause when we were about halfway through and we're saying we are putting a huge amount of effort of the people who are actually supposed to ship software as opposed to VPs whose effort seems to be free and we can just allocate them to do whatever.
The first thing we wanted to do was build a system that completely emphasized agility. We wanted maximum responsiveness. We didn't want to focus on utilization anymore. As an industry, we've been hyper-focused on utilization, and that hasn't really been working. In a CPU with a really deep pipeline, the cost of a bad decision is exceptionally high. Part of the reason is that system has been optimized for utilization. When you shrink the pipelines down and you parallelize them, you end up getting feedback sooner, and when you do make a bad decision, you know about it and you can integrate that change. That makes the whole system more flexible and more responsive.
And you know what? This is New Relic. We're data nerds. So we wanted to drive this thing with some data, do real analysis, and really understand the problem before we came to it with a solution.
One of the things we wanted to do was include every team's point of view and get every individual's voice out there, because that's really important to us culturally. And by and far, the most important was we didn't want to change any of the things that were good about the organization, because that's why we were here.
So we broke it down into 3 phases: analysis, design, and rollout. And for all of these, the key is that the engineers are making the decisions. As Cory said, we had stuff in our organization people really liked. We wanted to make sure we didn't ruin the specialness of New Relic trying to fine-tune a detail. But we also knew that there were real problems behind these delays or behind that distrust, and we wanted to treat them seriously. The people who have the information about what's working, what isn't working, where the problems are, where the solutions are the people in the teams. And so again, in all phases, we wanted to let those individual contributors make the decisions. The first step of analysis is figuring out how we can break these dependencies. Cory's team distrusted another team because they let them down. Well, why did Cory's team need that team to do that work in the first place? Let's take a look at what the dependencies in our organization are. That's this. To generate this map, we took all of the teams sent a representative into the lunchroom one day, and we put up these cards, big colorful cards here, and wrote the names of the teams on them. We then wrote all of the internal products. What does a team provide? And we drew arrows from one to the other to show which teams used those internal products. As you can see, it's kind of gnarly. This, immediately let us know that we were dealing with a big problem. So we weren't wrong. Our gut was that dependencies were an issue, and the data shows it. But being data nerds, this data is kind of hard to parse. we needed to turn it into a beautiful digraph. So we took out a lot of the duplicate edges. You thinned it down, the information that wasn't really telling us everything. Like every team depends on the network to be functioning. Well, has the network functionality been a problem in any project in the last year? No, not really. Well, let's take it off the chart. Like that simplifies down to only these dependencies which are sources of blockers in projects that we analyze. It turns out that's still quite a lot. There are a lot of dependencies between teams that were very meaningful. And we needed to change this.
So what we did is we got together to design a new structure for each of the teams. And when I say we got together, I mean we, the engineers, got together to figure out how are we going to design new teams. Each one of the lines on this graph is an opportunity for one team to cause another team to be unable to fulfill the delivery of their product. And the only way to do that was to get rid of the edges.
So this is the first diagram that we came to. This is was crowdsourced. We went to all the engineers. We involved people. Over a period of several weeks, we looked at several different designs, and we came up with this. It doesn't look a lot better. It actually is. I took the labels off of this, so it's hard for you to see that. What we've done is we've removed some of the more critical dependencies and replaced them with less hard dependencies, but there's still way too many dependencies on this graph. What we need to do is to get to something that looks more like this. Ah, man, that's a totally sweet dependency diagram, right? There's like some teams here totally independent. Everything else looks pretty simple. You could really understand it. Getting to this requires changing the way that we work. It requires embracing a self-service model for our teams. This proved to be culturally difficult because New Relic has made a habit of hiring helpful, friendly people. And helpful, friendly people want to help each other. So when I say, hey, I'm having trouble figuring out how to use the new charting API.
Dude, I'm on it.
Right, see, Cory comes down, he sits next to me, or he just like solves it. He's like, here, I made it work for you because I'm a helpful guy. But this is creating these tight dependencies that go on and on. What we needed was a relationship more like the one that I have. Like if I go home and I build a system, I'm going to build it using AWS. I'm going to use lots of their services. I'm not going to call my friends who work at Amazon and say, hey, can you help me deploy some EC2? I'm going to read the docs. I'm going to use APIs. I'm going to use self-service UIs. I'm going to do it all myself. And it's maybe a little bit slower, but it eliminates that dependency. And we needed to create that type of relationship between our own teams as we would have with our SaaS vendors.
Ultimately, what we were trying to do was build stronger teams. And when we said stronger teams, we meant that what we needed was for our teams to be as independent as possible. And we needed them to be free to make their own decisions about how they were going to build amazing products.
So we call this full ownership teams. A full ownership team has everything it needs both to define the problem, so the business components, and to execute it, to solve it with the technical components. So this team contains a product manager on the team. It may have a designer on the team to help the product design. And it has engineers who cover all of the necessary disciplines so that if you have a product that has a rich JavaScript user interface, it's got some middleware, it's got some high throughput data services, instead of splitting those out to different teams to emphasize on utilization, where we say, oh, you know what, this is a team who does a great job with high throughput Java, so we're going to farm their work out to them. This is a team that does a great job with front-end JavaScript, so we're going to farm this work out to them. That's great when everything is running perfectly, and those teams can move through those tasks very quickly. But we learned, running perfectly is not the normal state of a product organization. Kind of hanging on like the skin of our teeth is the normal state. Like we're trying to push the envelope, and that means that things are going to be unpredictable. So bring all of those disciplines into one team, and even though that team might not be as efficient from a utilization perspective, they can make decisions using their on-team product owner, and they can execute on them no matter where the choices lay. However, this required changing the definition of what makes a great engineer. If your teams are focused on technologies, then a great engineer is somebody who's ultra deep in that one technology and could really push the state of the art in front-end JavaScript or in high throughput back-end systems. If the team has to do lots of different things, then the engineers look different. And we say that these engineers that we're looking for are T-shaped engineers.
I'm more of a pear-shaped engineer, so this was a pretty foreign concept to me. when we say T-shaped engineering, what we're really referring to is every engineer on the team has their vertical, they have their specialization, but they also have breadth across all of the skills necessary to make that team viable. We went ahead and defined viability as being able to maintain the systems that your team owns and deliver on your roadmap. And that meant that we needed to be able to cross-pollinate.
Ultimately, all of this is really about taking our organization and inverting control, right? We want to move the decision-making capability into the team, and we want to move all of the things that you need into your team. So we create autonomy, and we create true empowerment as opposed to kind of empowerment program empowerment by giving the teams the tools they need to make decisions and execute on them. This kind of makes my job as an executive a lot easier, if a little bit scarier, because I don't need to go through and sequence all of the tasks that are going to run this project. Instead, we say, well, the team should be able to execute on this, and I have to trust the team. Everything we're talking about today really comes down to, are you putting enough trust in your teams, and how can you put more? When we looked at that design, we said, well, you know what? We used our teams, we used the individuals to analyze the problem. We used the teams, we used the individuals to design what the new team structure would be to set those viability. But now we know that our new teams don't look like our old teams. We have to populate them. We got to put people in those seats and form those teams. So the only logical way to do this at this point is self-selection. The idea seems completely nuts when we started, but once you start down this road of looking at how you can push more control down in your org, how you can create more autonomy, and you say, you know what? There's nothing that gives more ownership to the team than to have the team form itself. Of course, this is a lot harder than it looks. And it sounds super great in a meeting when I'm pitching my boss and saying, guess what? You're not going to get to pick the teams. Instead, the engineers are going to pick their own teams. They say, OK, you know, that seems nuts, but you're a crazy person, and we're going to sign on to it. Doing it required a lot of jumping through hoops. And the first one was kind of obvious. Managers weren't into it, right? Managers have defined their careers by finding the right people to form their teams. I'm matching these skill sets and these personality types to form these roles. I'm going to get everybody to make this team really hum. And self-selection is not manager selects team. It's engineers select the team that they will work on. The manager is not allowed to say no. If somebody comes up to you and says, I'm joining your team, you have to say thank you. So obviously, not amazingly popular. Luckily, managers are used to doing things they hate doing all day long. It's kind of the job. So pretty much they got in line. Pretty much.
Yeah, so here's the thing. The engineers really didn't like it very much either. And that's kind of counterintuitive, because if someone comes to you and says, hey, how would you like to pick your own job? That sounds fantastic. Except that we are engineers, so we automatically go to the worst case scenario. That we had a lot of people at the company who didn't like the concept of change. We had people who didn't want change at all because they had a good thing going and they didn't want to leave that. And we did actually have engineers who thought that this was a really fancy way for us to do a headcount reduction and call it something neat, and that they wouldn't have a job at the end of it. That was a very legitimate fear.
There's a ton of fear about this. And I think part of it is that, honestly, even before we pursued this practice, you know, warts and all, New Relic is the best place I've ever worked, right? And so you say, why am I going to take a radical change and gamble a great company? And that put fear in people. There's also maybe like a kind of being picked last for dodgeball thing. Let's be honest, engineering is full of people who were not picked first for dodgeball. And so there was a lot of social dynamics around this that people were just genuinely worried that they would end up with teams that were about popularity and not about skill set and not about fit. So, you know, I'm going to be honest, we almost backed down, right? You know, I was at this point facing a lot of people who I'm trying to help who are telling me that this is making them miserable, this is destroying productivity, and they're going to quit the company because they're not happy with just like this level of just like dread. And I'm having to go upstream and say, yeah, no, this is a great idea. Like, we should do this. It's not going to kill your company, to my bosses. Luckily, my bosses are Mikey Butler and Jim Gochi. and they were all in on autonomy. And so when I went to them and I said, well, we've got some problems, they pretty much said, we don't care. Like, if you truly believe that the decision-making ability in your organization needs to be given down to the teams and given to the engineers, then we must believe that the people who are best suited to make decisions about their own careers are the engineers themselves. And so we move forwards. We did have to do some mitigations. We spent a lot of time communicating. We got up on stage. I got again and again and told people, we are not reducing the number of seats, right? This is a company that is growing, and that this is a company that cares for your career. Before we did self-selection, we were invested in your career. We would make sure if you were unhappy on your team that we brought you to another team where you could be happy and successful. Going to self-selection doesn't change this. We had to just beat this drum and let people know that although we were giving them the capability and to make a choice, we were not taking away from them our obligation to look after our engineers.
That actually meant a lot to me. I was pretty anxious leading up to the event, until it really dawned on me, and they got up in front of us the day before and told us in no uncertain terms, if you don't like where you ended up, you still have a home here. This is still where we want you to work. It took my anxiety level way down far enough that I could really look at the problem objectively, and I realized this was a good change for us. So the day arrives. It's time for us to go through this absolutely insane thing that we're going to do. We reserved an offsite. We put tables in it. Every table had a big old balloon on the top of it with the name of a team written on it, and it had a placard on it that listed out what the skills were necessary for this team to be viable. And we come in the morning, and we get to look at them. So leading up to this, I had already decided I was not going to change teams. I had come to work at New Relic to work on a specific team on a specific product. I really liked the people I worked with, and we were really efficient at building products. And I was in the car on the way to the event, and it's about a 20-minute drive. When I got in the car, my mind was made up. As I was driving, I kept coming back to the thought in my mind that, my anxiety was really, really high, and now it's not. I probably ought to keep an open mind about this, because no matter how it turns out, there's something beneficial for me here. We got down there, we walk into the room, and I see this, and my brain starts to go fluttery a little bit. And then we're told, you know what, everybody needs to get up from the table that you're sitting at and walk around and learn. And so I started doing so. And something immediately jumped out at me that I was surprised by, and that was that there are a lot more balloons in this room than I thought we had teams. And as I started walking and looking at each sign, I started to realize, wow, these teams all do really cool stuff. I'd come into this with the assumption that the skills that I had from my career were really isolating, and I had very vertically specialized in something specific. And that meant that I wouldn't have skills that were applicable elsewhere. That was completely wrong, because we as engineers had redesigned all the teams to make sure that they all had these skills. I found 9 teams that were doing really cool work that I all really, really wanted to work on. And I kept finding myself circling around one particular table, and that was Insights. And it was our flagship product. It was really, really cool. It was built in a bunch of stuff I didn't know. And the next thing I knew, I just sat down at that table. I instantaneously made a decision that I was going to take a risk and change my career.
Yes! Victory! So, I went into that event. We'd been doing a lot of planning, a lot of work, wargaming this stuff back and forth, and we really didn't know what was going to happen. That's how autonomy works, right? We had handed control over the company to the individuals. Maybe they're going to flip over the tables, they're going to light everything on fire, they're going to dump the coffee pots out, we're going to be out of our jobs. And maybe people are just going to sit at their tables, they're going to say, look, I'm not interested in all of this BS, I'm just going to keep here working on this team. And we had lots of projections about how many people we thought might shift and what impact that would have. We ended up having a third of the people who came who could change teams, right? Just a huge number. And it's, even if they didn't, I felt like, as Cory's telling his story, he says, I went out and I saw all the great teams doing great work. At that point, we'd already won, right? We've taken a company that maybe has a little bit of the us and them feel, where you say, well, this is the team I'm on, and if I don't like what I'm doing, you know, I'll do what everyone does, and I'm just going to quit the company and go work somewhere else. Instead, say, no, this is a place where you have career opportunities on 8 other teams, right? You know, you could go and change to do something that's totally different than what you've been doing and is also cool. And it humanized those teams too, because you say, oh, well, here's the goals of this team. Now I understand what they're about. But better than that, you know, Cory did change teams. Lots of people changed teams, and so we're cross-pollinating different parts of the organization. People who worked in mobile working in insights, people who were in our front end going into the back end going into the front end. A fabulous opportunity to bring those skills together. This is the kind of opportunities that self-selection revealed that we couldn't see. There's no way that I could have done a list and I would have said, you know what? Insights team, Cory Johannsen, right? You know, I would have left him on his existing team. Like, I would have said, Cory's been pretty happy. He's never complained to me publicly about like wanting to switch teams, so he doesn't want to switch teams. But it wasn't about, is Cory pretty happy? It's about, you know, what are the opportunities? What are the skills? And so there's a huge opportunity for your organization to let people reveal parts of them and kind of sides of their career that you don't know about.
Here's the fundamental fact about this. I could never have applied for this job.
Not looking like that, man.
No, no way. I mean, that guy's an idiot. My resume, if it's submitted for a position on this team, would have gone straight in the trash. I had none of the skills you would need to be a contributing engineer on the Insights team. Right up until you start to look at what we had done when we changed the teams. Originally, Insights didn't have a whole lot of back-end processing. When we rearranged the teams, it did. There's a Kafka consumer that's reading from our metric names. That's a big pipe of data. And it's shoving that into an Elasticsearch cluster. That's new. We didn't have that before. We've got a whole new set of services for querying all that data. We also have this edge component where all the custom data flows into the system for custom events. That was all new to the team. The people on the team didn't have the skills necessary to do that, and I did. And that's when it suddenly really clicked for me. I get to teach these people how to do this stuff, and in exchange, they're going to teach me how to build JavaScript user interfaces. I didn't even know the language. I didn't even know the frameworks they were using. I couldn't communicate with these people about the technologies they used. But it was still going to work, and it was going to work because we were all going to take advantage of the fact that we could work together to solve these problems.
So as the teams formed, we ended up, you know, we worked through a couple of rounds, let people move about, and ended up with our org structure set. We now knew who was going to form each team. And the next thing to figure out is how are those teams going to work? Just like the engineers have decided the team structure collaboratively, they have individually chosen the teams they're going to work on. Now as forming the new team, they need to set their working agreements. A working agreement is the completion of this sentence. It says, we work together best when something, when Nick doesn't do all the talking. We work together best when we have meetings only in the afternoons, or we keep 3 days a week clear. They can be very mechanical. They can also be aspirational about how you develop your product or with the processes that you follow. But the important thing is that they're different for every team and that the teams get to set them themselves. These are ways for the team to establish their own practices.
It was the very first thing we did after we formed our teams. This is my team. That's my shoulder in the corner. If you'll notice, I'm also the one looking at his computer at the time.
I'm sure you're looking up something vital. It looks like Google Calendar.
Yeah, I'm looking at the calendar, scheduling a meeting, I'm sure. We decided that the 3 most important things for us to get our jobs done and build good products was that we were going to do weekly demos and retrospectives so that we could get feedback fast on what we were building. We wanted to do continuous deployment so that we could get changes out in front of internal and external customers as rapidly as possible to get feedback back into the process to integrate it quickly so the cost was low. We decided we were going to do mob programming, which, if you're not familiar with it, is insane. It's literally one computer and your entire team shares it and you rotate who's on the keyboard. It's like pairing, but on steroids. When it was first proposed, I was apprehensive. Then I actually thought about it for a second, and it's like, you know, self-selection was crazy. Letting engineers design our teams was crazy. And so far, that's working out pretty good for me. I probably ought to keep an open mind, and I'm going to engage this. And I was a really vertically oriented developer my entire career, so working this collaboratively was really new to me. And the thing is, as we started working, we found that we had a really, really good group of people to do this, and it actually worked. The thing is, within a couple of weeks, we started shipping actual functionality, real functionality. And I didn't even know how to do any of this stuff when I joined the team. First thing we wanted to do as a team was pick something we could build to prove that the investment that we made was worth it. So we chose to do CSV export. It's a relatively easy thing to build. It's low-lying fruit. It was something we could build reasonably quickly. We did it in a couple of weeks. We got it out in front of our customers. It had a high customer value. And it proved that what we had done, the decisions that we had made as a team, were solid. And that meant it was time to bite off something bigger. We wanted to do unified dashboards. We wanted to put metric charts next to Nurgle charts inside the dashboards. That meant building an entirely new dashboarding system. And that meant being able to pin charts into those dashboards from anywhere in our product. Then being able to edit it once it's in there. And the thing was, every week, we as a team chose which piece of the system we were going to build next. And then we chose when we were going to roll it out and how we were going to test it. We kept investing more, and something really, really amazing started to happen as we started accumulating more and more functionality and getting feedback from our customers and integrating that feedback rapidly. A, we were building what our customers wanted. B, we were proving that our team was highly efficient. And then the real magic started to happen. This is the Metric Explorer. This thing is relying on a bunch of systems that didn't exist before this team joined, built on a bunch of technologies that I was the only one who had much knowledge of, including Elasticsearch, which even I had never worked with. We built a user interface, we built a bunch of services, we got this thing up, we got it scaled. When the team first started working on this problem, our GA date was going to be sometime around FutureStack. We delivered it in early October. We delivered it without cutting scope. That gave us time to build the time picker, our single most requested customer feature since the product launched. We thought, we're barely going to get this done before FutureStack, so we're only going to do the open-ended time windows for the last couple of days. That took 2 weeks. So hell, let's do the custom time picker. We'll do that too. That took a week. We had a dead week. So we built Copy Dashboard, and we shipped that last Thursday. Every week, every week at our weekly demos, we would go over what we'd done, and not only had we built what we committed to without cutting scope, we were ahead of schedule and we could start the next task. And we kept pulling the calendar in, week after week after week. We took a 12-month roadmap and built it in 6.
And these results are, they're, whoops. Yeah, I'm wild with the clicker today. These results, looking at these 6 features that come together, it's not just that we had a brand new team was able to deliver 6 features faster than you would expect. Even though they weren't familiar with the technology, they were using a completely crazy way of doing development. It's that those features are high value to customers and they're in customers' hands, right? All this stuff was shipped out the door. You've seen it on stage this week at FutureStack. And the team is able to, by working with their product owner in the team, make quick decisions. Say, we have a week left. What can we ship? How about dashboard copy? You don't have to go up the management chain to make these decisions. And because they own their whole stack, everything underneath, they own that Elasticsearch cluster, they own their mid-tier, they own their JavaScript, they can do it in-house. Cory's engaged, Cory's happy, I'm super happy because we've cleared this roadmap out. Everybody's winning. So when we talk about this, it's like, all right, that's pretty cool, right? I like winning, but how do you do it in your own org? Do you need to dedicate like 10 engineers for 4 months to get this done? I don't think so. I think most people are not ready to take on the full, like, what we call project upscale, the reorg and all of these things. But there's some key elements inside of this that you can take that can apply to any organization. The first is that you hire smart engineers, trust them. Trust them to do things that you wouldn't otherwise trust them to do. Let them go and meddle in the organizational affairs. Let them make decisions about what they're working on next and how the team is going to work. Every time that I have taken a step back, kind of taken my hands away and let people make their own decisions, I've been rewarded. Like, it turns out well. People are capable of far more than we think they are.
When you look at your teams, you need to look at them and say, we need to optimize for vertical ownership, and we need to shorten the pipelines. It's really, really important that you focus on agility and frequent delivery, because that allows you to get feedback fast and make changes before the cost of making those changes is too high and the risk is too high.
So ultimately, all right, better teams make better products. As we said at the beginning, I'm not doing this just because I want Cory to be happy, although I do want Cory to be happy. Look at that guy. But I'm doing it because I want to ship great software. And the way you ship great software is to invest in your teams. The teams are the ones who are making the software. I don't make the software as chief architect. You know, the other VPs, we don't make the software. The teams make the software. The teams are where you need to invest. Of course, we didn't go into this alone. You know, in order to figure out all of this stuff, we had a lot of help. So, this guy here, this is Jim Shore. Jim Shore is a consultant. He does this type of agile at scale. You know, this is his bread and butter. He works with companies who are facing these types of issues and figures out how to get us out of these problems. He also wrote this book, Art of Agile Development, which talks a lot about these topics. He's the one who brought us the concepts of self-selection, who had said, hey, you know who should really set up your team design? Your engineers. All of those things, he was encouraging us to push ourselves further, and he worked with us through the process. It wouldn't have been possible without him. These books are also great resources if you're interested in the type of working agreement and team formation exercises. This book, Liftoff by Diana Larson, is where those exercises are taken from. And this book here, Creating Great Teams, is basically the reference on self-selection. It's a pretty new topic, but it's actually something that a number of much larger companies have been doing for a long time, really trying to find ways to harness that creative energy and create autonomy on teams by letting people make their own team choices. And so if you're interested in the topic, this is my recommendation.
Thank you all so much for coming out to hear us. We hope you found something interesting here. My name is Cory Johannsen. I'm a senior engineer on the Insights team.
I'm Nick Benders. I'm the chief architect at New Relic. Here are our Twitter handles. If you have any questions for Cory or complaints for me, you can find us afterwards or you can shoot us a tweet. Thank you very much.